So today I'm going to show you how to program the ARM processor on this module, the EMB1061. This one has the BlueNRG from ST ARM processor, and in this video it's just going to focus on playing with the ARM processor. Next video we'll do an actual Bluetooth service to communicate back and forth with the phone. So let me show you what I have. So this is my setup. I have the UART port connected to the Pico and the Pico UART port connected to the HM11, and then the HM11 will connect to my phone. Also have two LEDs at the bottom. This one connected to pin number 3, pin number 2, green and red. So if we're successful, we'll be able to play with the LEDs, and hopefully we'll be able to send data to this one and then see it on the phone as well. I will also show you where to get professional boards for this module, so you can get them and you don't have to do them yourself. So let me switch my view. This is the data sheet for that that module. So these are the two UART ports, pin 10 and 11, and the LED 12 and 13, which translates to 10 and 11 to pin 8 and 11, and then the 12 and 13 to 3 and 2. And this person here in YouTube has a template ready to go, which is the one we're going to use. You can also buy the boards directly from him as well. You can see there's nice boards, professionally made. So let's go and download the file. So he has all the instructions here, easy to follow. We'll download the project. Let's go to my downloads. Here it is. Let's minimize this. I have VS Code ready to go, and I also have the my folders. Where's my other folder? So I have two folders ready to go as well, and my downloads here. We'll create a project folder for this new Bluetooth. So we'll call it BlueNRG, which is the name of the processor. And we'll copy the contents of his project into that folder. Down here, I have the SDK for BlueNRG and also the toolchain or the compiler to compile that project. So let's wait for this to copy. Okay, so this is my project. I'm gonna open it in Visual Studio Code. And so the instructions, you have to make changes to the settings JSON file, just to make sure it compiles and it can find the SDK files. I'm gonna delete what I don't need, and I'm going to let me update those. So first, we're gonna update the bottom one, which is the SDK location. We'll copy that path, put it there. Then we need the compiler. I guess I don't know if it's called compiler or not, but that's what you need. Copy this path as well. Now press Control H to bring up the replace function, and I'm going to replace the backslash with /. And that's it. As long as you don't have any spaces, this should work. I'm going to open the make file, and instead of having the link directly, my system has a lot of restrictions, so I am not able to get to those. I'm going to copy those manually, so I'll create the folders required for that. The first one is libs. Oops. Second one will be for objects, and I'm going to move these files into this folder here. So we'll start with where is it? the peripheral. We'll move those. Where is it? Right here. Next. Okay. Hit the clock, utility, OSAL, and then sleep. Bring it over. Need the SDK. Also need this one. Device, ST, source, one file. And then the user, stack user config. Bluetooth LE. There it is. Okay. Let's see. Let's try to compile it. It's gonna give me some errors. And again, this is due to my system restrictions, so I have to make some changes. First change is that I'm not able to create folders from here, even if I open it as an administrator. Also, this does not work for me and is not needed because I copy the files by hand. So I should be able to compile now. Let's see. What did I forget? Where's the one I commented? Oh, that's the wrong one. Let me see. This one here. Let me go back to this one. Let me compile again. There it goes. We should be able to see the bin files pop up. Well, they're already here, so let's give it a different name. Compile again. And we'll see the other one pop up here. There it is. So we have a successful bin file. So now what I'm going to do is I'm going to convert this to a structure that works with C++ because I'm more comfortable with C++ than C. So what I'll do is go to the main file, and I'm going to remove everything and include just something simple, stdio, and then an empty main returns 0. I should still be able to compile, no issues, right? It's an empty file. And now for C++, we're going to have our own folder structure. Call it CPP, and inside that one we'll create a couple of files. Main CPP.header file, and the main CPP.source file, or CPP. We'll add a couple of folders, one for header files, and one more for source files. Move the source to source, the header to header, or include. And in this one, well, actually in this one, we'll include the main CPP.h and include the clock. The reason I'm including the clock is to force the linker to expose an error that I need to fix. So I'll have an empty main here. This is going to be our main loop, system loop. And here I'll have the clock, wait 100. Again, this is just to force it to give me an error so I can go and fix it. We'll go to the header, and we want to put some, I don't know what they're called, compiler extensions, I guess. Not extensions, but C++. This is to make the main function, the one I just created, make it visible to C, so I can call it from C and jump to C++. Okay. Okay, that should make it visible, and I'll call it from this file. So this is gonna give us just branch over to the other file or to the C++ side of the code, and then we won't use this part anymore. Main cpp.h. Here we'll go directly to the function. If I compile, obviously it's not going to compile because it is a different structure. The files have a different extension. So we must modify the make file to include those new sources. Okay. And CPP. Want to make sure that they are included. One. CPP files. CXX. It is good. Want the includes to be visible as well. Last, want to compile them. So we'll copy this and add it here. And that should allow us to compile. So let's compile. Oh, there it goes. All right, so this is the error that I wanted to expose so I can fix it right from the beginning. So the script doesn't have, and this happens a lot. So the script itself, this file here, it doesn't have entries for this ones, for C++. This is just an error handler part, something like that. Let me make it bigger so you can see it better. So we need to add the stubs for this function and this one, and then the other one that went all the way to the right. I think it went to the right. Right here. Okay, so we'll go to the end of the file and add arm, and then add this part right here, exidx, and inside here I can add the functions themselves. So I'll add this one, the stubs, and this one, and this one. So that should allow me to compile, and I shouldn't have any more errors moving forward. We're good. When I compile, it created the whole thing. So let's light up the LED. Close this file. Close this one as well. And now that we are here, we can include what is the blue GPIO? This one here. Oh, the only thing we have to do on this one is call the system init and the clock init. Obviously, we have to add it. Let's bring this over as well. Okay, let's initialize the pin number 3, the GPIO. And to initialize it, I'm gonna just branch over to where this one is defined. So I'm gonna have the cursor over, press F12, it'll take me to the file, move it to the side so I can see what I need to do. So we have 4 properties that we need to set, and init type. So I'm just gonna call it init type. So it's a structure, and we have to set 4 properties. So the first one is gonna be the pin, GPIO pin 3. Then the mode is gonna be output. The pull-up will be enable, and high power will be enable as well. Another thing that we need to set is this, the what's it, the clock? Is that the one? Is a system clock or system peripheral clock command, that one. So we want the GPIO or clock for GPIO enable. GPIO init. That should be it. So now we initialize it from here. And here we can just toggle the LED and see it working. So we'll do it every half a second. GPIO toggle GPIO pin 3. Let me compile, make sure everything works. All right, everything seems to be okay. Let me display this thing. So we should see the green LED start flashing when I move it over. So let me bring up the BlueNRG SD-Link utility. And here's the file. That's the path. I'm gonna program it. Say start, and then we should see that thing start flashing. There it is. You can see it. Not very bright. It has a 1K resistor on it. So let's make it a little bit faster. Every 1/10 of a second. Compile again. And we should see it move or blink. There it is. All right, so let's send some data so we can see it on the phone. So we'll display it here. It'll just start scrolling up. So let me have a full window here. So for the next one, we need to add a header. And we will need this stuff. UART. Okay. The difference here is that instead of output, and obviously it's a different pin, so it's going to be pin 8. And this is going to be serial mode. And these ones are going to be disabled. Here we will use the GPIO and the UART. Enable both of them. And then we'll call that one. That's just for changing the function of the pin itself. Now the UART functionality has to be enabled. So for that one, we need to do UART init. And we'll do the same as the other one. I have my cursor over it. Press F12, so it takes me to the definition. Bring it over here, so I can see what it has. Move it over. So I have a lot more properties I need to set, and it's based on the UART type, init type. So we'll do it here, and we'll call it init U type. Okay. just for easy typing. We're not going to use it anywhere, just here. So init u type, we'll set the rate or the baud rate first. Actually, let's do that as a parameter. 32-bit speed. Okay. The next one is the word length transmit word. So this one, 8 bits. And you type receive, same as the previous one, 8 bits. Stop bits. One. None for that one, I think. Parity, no. And mode, where's mode? Right there. So mode will be, so I have two, I have RX and TX, and we're gonna do both. So we'll do RX and TX. What is the next one? Hardware flow. None. And the last one, enable. Okay, so what do we do next? We have to enable UART command. Enable, and we have to init u. And I'm not sure if this one's needed, but we're gonna add it. That's how they have it under standard definition. So it's UART RX50 config, and this is the one they use all the time. I haven't had a chance to test to see what that does. In any case, we'll enable that part. So init UART, and it's going to be, the starting speed will be 11,5200. And to send data, let's just add something here. This is a test. Okay. So every second that message will come across to my phone. Let's do a loop. So actually for index less than the length of the buffer, index plus plus, and UART send data buffer index. Okay, we should really be checking to see if the buffer is full, but we have a second, so we're not going to do that in this demo. What else do we need? Let me compile it. All right, I have errors. All right, we need to specify where this is coming from. And I believe it comes from string. All right, compile. So let me let's play that now. And load the new file. And if everything works, this will blink every 1 second, and we'll see data here every 1 second. So there's the data coming. This is a test. So that's the end of this demo. This is just for playing with the ARM processor on this module. On the next one, it will be for doing a service for the Bluetooth module, and then possibly adding the AT commands. So it's going to be a long video, a lot of programming, a lot of writing code. So again, this project can be downloaded from that person's site. I'll add the link on the description where you can download it, and then you can follow the video if you want to do any of this. And I'll upload this project's files as well, so you can download them if you want to. But I suggest you do your own so you can learn and do your own thing. So until next video, hopefully it'll be on Friday or before Friday. Uh, you know, depending on how much time I have to get this done, since I'm full of work all the time. All right, enjoy, guys.